Hello, everyone. I'm Stephen Hardy, Editorial Director of Broadband Technology Report, and welcome to our BTR Tech Panel, Docsis on the Road to 4.0. Thank you very much for coming. Our session today is sponsored by, if I can just get this to work, there we go, ATX Networks, Technetics, and Corvo. And of course, we thank our sponsors for making this event possible. And of course, we thank you and the audience for attending. So if you've been to SCTE Cable Tech Live in the past, you perhaps have been to one of BTR's tech breakfasts. Of course, that's not possible this year. And since they have not been able to virtualize bacon yet, we decided that we would hold it in the afternoon rather than in a breakfast setting. So, of course, we have a rather large panel of experts that I'm just about to introduce. And for that reason, you have now seen all the slides you're going to see. So just to confirm with our technician, I am now finished with my slides. So let me introduce our panelists, and perhaps the panelists can give a small wave just in case the identifiers on your webcams aren't visible to our audience. We'll start with Jan Eriksson, Chief Technology Officer at Technetics. Technetics, of course, is a technology company focused on enhancing broadband cable network performance worldwide. Its RF and optical access technologies enable its customers to optimize their core HFC assets as new innovative technology pushes boundaries in the application of distributed architecture. Jan is an experienced engineer with more than 30 years of broadband cable TV design experience. He currently leads the CTO as well as the marketing, PLM, R&D, and QA teams at Technetics. His main focus is to liaise with key customers and be the Technetics technology advocate, developing new technologies and product platforms. Jan joined Technetics via the acquisition of Tradetech in 1983. Before 2008, Jan was Technetics Vice President of Engineering, leading teams in the UK, Belgium, and the Netherlands. And Jan joined the Technetics board in 2018. Next, we have Jay Lee, who's Chief Technology Officer and Chief Strategy Officer at ATX Networks. ATX, you undoubtedly know, develops and markets broadband access and media distribution solutions. The company is currently focusing its RF and outside plant expertise on the long-term evolution of the HFC network. Jay is responsible for product development, platform strategy, and operations for all RF access networking solutions, possessing many years of highly specialized RF and optical technologies, and experience in that, and understanding of the broadband business environment. Jay has been a catalyst for the company's growth since joining in 1998. Prior to ATX, Jay worked as an engineer for Schlumberger and at Siemens as an R&D design engineer. Next, we have Ben Clay, who's president and general manager of Stratus IQ Fiber Internet. As the name of the company implies, Stratus IQ of Colorado Springs, Colorado, provides residential and business internet services mainly via fiber, but the company, formerly known as Falcon Broadband, also serves about 500 customers via HFC. And so Ben faces the challenge of delivering high quality services on both infrastructures, which is why I thought he would be a great addition to this panel. Ben's career experience in operations management from the IT service industry revolved around reliability and customer service, and he focused on these areas when he moved to Colorado Springs in 2007 and took on the role as general manager of Falcon Broadband. In 2018, he was promoted to be the president and GM, where he added value and quality to complete the 4 pillars of the new brand, Stratus IQ. And Stratus IQ has rolled out new products with help from the NCTC. The company is proud to be voted #1 broadband and internet provider in 2020 from the Colorado Springs Business Journal. Next, we also have Dr. Curtis Niddle, Vice President of Wired Technologies at Cable Labs, and I assume you know what Cable Labs does. So I'll tell you that Curtis and his team are responsible for specifying scalable deployment solutions in both hybrid fiber and coax and all fiber access networks for Cable Labs member companies. Docsis technologies, full duplex Docsis, distributed CCAP architectures, and point-to-point coherent optics are a few current high priority projects under his leadership. Curtis also is the chair of the IEEE 802.3 CA 50G EPON task force, which just completed standards work on the first 50 gig PON solution. Finally, we have Dean Stoneback, who is Senior Director, Engineering and Standards at Scte. Dean joined Scte in 2014 after having more than 25 years with General Instrument, Motorola, and Aris Group. With Scte, he is responsible for the development of standards, operational practices, and training material for the broadband communications industry, with specific targets that include reducing energy usage through the Energy 2020 program, assuring that networks are ready for Docsis 3.1 and 4.0 deployments, enabling advanced IP video services and advertising technology, and supporting the migration of networks from coax to fiber delivery. So what we're going to do here today is have a discussion about technology. This is under the theme On the Road to 4.0. So that means we'll be talking about 4.0, but we'll also talking about some of the technologies that will get us from here to there. I have a long list of questions that I'll use to at least get the conversation rolling, but we want to hear from you out there as well. So you'll be able to forward questions through the questions box that you should see on the right-hand side of your screen. Just click in the box and type in your question and hit the submission button. Now, don't be concerned if you don't see your question added to the list right away. There's a moderating function that I'm in charge of while I'm asking questions. So I'll be hopping back and forth between this screen here as well as the moderation queue. And so I'm sure you'll see your question added to the list very soon. And with that, let's get going. Maybe we'll start with this. Of course, it's kind of tough to talk about the future without acknowledging some of the things we've been going through in the present. So maybe we'll start with you, Ben. What has been your company's experience this year in dealing with the changing customer requirements that the COVID-19 pandemic and work at home, stay at home have rendered in your area?
Yeah, thanks for starting with that. We've seen huge increase in demand from customers, large increases in usage, but also increases in product demand from customers who want to get higher speed plans. We feel kind of lucky, actually, but we believe that luck favors the prepared. We feel like we prepared our HFC plant specifically for this type of usage. A couple years back, we expanded our CMTS shelf. So we added a second shelf. We made sure that all of our upstreams from the CMTS were 10 gig upstreams. And then we also dedicated service groups, one service group for every node. I think that made a large difference. And we dedicated channels in a contiguous form across our spectrum to bandwidth, and we made sure that those channels were separated from our noise floor. And all of that has had a really good impact on our plant, and I think had us prepared for the amount of usage that came around with COVID. And so we definitely saw that usage go up, but we felt like our plant handled it very well. One other thing that we did add, though, from the NCTC is we added the Plume system for optimizing Wi-Fi, and we think that helped out a lot. I think that customers, not only were they utilizing more off of the system, but with kids at home trying to remote learn and parents at home trying to work from home, that just put a lot more stress on the in-home Wi-Fi situation, and we think that Plume product really helped out there too.
Mm-hmm. So maybe to get a wider look, Jan and Jay, I'm interested in what your customers report having done in the face of the pandemic. Maybe Jan, why don't you start?
Yeah, no, I think it is what Ben says. I think what we see happening is that with this COVID, there is a lot of pressure for more data, more customers, etc. And a lot of the focus has went from the access to the in-home networks, CPE equipment, etc. that can cope with the higher speed, the higher demand for speed. And I think also with the restriction of construction work and so on that was happening on the street, those two has stressed the access network. and because we had more customers, and the customers in fact needed more data, and that what was I think was was something that happened due to this COVID, that the in-home network was more focusing on the access network, and that's why I think this whole subject of going to Docsis 4 is a nice start to go to the next step, because the Docsis 4 now should make the access network ready to cope with the demands from the home.
Jay, what are you seeing?
Yeah, I'd say from our perspective in talking with various customers, certainly what one might call strategic technologies or network evolution-based technologies, those initiatives were probably pushed out to the right a little further as MSOs, for lack of a better term, scrambled to adapt the capacity increases that occurred in years worth of capacity increase occurred within like 2 weeks. So there was a lot of just what I would call BAU or legacy type activity, be it node split or service group realignments. One MSO I do know was fortunate enough to have completed a mid-split upgrade, and their network actually responded very, very well, and they didn't have to scramble near as much. And I know a number of MSOs have that on their roadmap starting in 2021 to sort of catch up. But in the short run, as COVID hit, it was all hands on deck and pretty much legacy upgrade type activities.
Mm-hmm. So Jay, you were just talking about people, potentially moving things a little bit to the right and having plans for next year. What do you anticipate? Any lessons learned during the current situation that might affect decisions made going forward?
Yeah, I think everybody's mind is now at this in some way, shape, or form. This will be the new norm, and in particular, upstream capacity requirements are going to continue to move up and to the right, and MSOs are recognizing they're going to have to adapt to that, and clearly. That's one of the reasons why Docsis 4.0 is going to be important moving forward.
Jan, what do you think the pandemic hasn't had in the way of an effect on future plans?
Yeah, I think it is, as Jay says, because most of our customers has proven that the network they have can cope with a lot of the stress. There was a lot of stress on the demand, etc. But most of our customers were able to adapt to it and deliver the service that they needed. But it is clear that we are now on the line that if this is the new norm and we start to work from home, that in the future we have to be able to have a bigger pipe into the homes as well. But I think if you look to it, our customers were all able to deliver the service needed during this COVID. But I think they were maxed out, so it is good that we can do an additional step with Docsis 4 going forward.
So Curtis and Dean, do you anticipate any changes in requirements or requests from your member companies as far as what they'll be requiring from your organizations going forward? Dean, why don't you start?
Thank you. Well, we see a lot of ongoing interest in training, and also related to everybody working from home, or not everybody, but more people and less in-person meetings. So our chapters have adapted very well to having virtualized meetings and virtualized training with attendance up, and a lot of good work going on there. So a lot of opportunities to virtually connect with others in the field and learn from each other, and as well as take some training ongoing there. So we see that as well. And in the standard side, we'll talk more about, I'm sure, the various standards that are enabling future networks. So it's very great activity, both on the training and on the standard side, and in the chapters and membership areas as well.
Curtis, what are you seeing in Cable Labs?
I don't anticipate much change in terms of requests from operators. If you look at the technology between the hub and into the home, we're pretty much covering every component in that technology chain, whether it's Docsis 4.0, Docsis 3.1 on the CMTS side, point-to-point coherent optics and coherent termination of that link, and edge devices and distributed access, and then the cable modem. So we've got those covered. Specs are either nearly finished or ongoing. So from that perspective, I don't see much of a change. Your previous question about will we see something accelerate as a result of this pandemic? I think the industry has a long history of investment, of course, and they invest to get ahead and stay ahead of the curve. And so I think from that perspective, the strategies of cable operators and their deployment plans, it'll probably remain as they are today. If there's little uptick in terms of acceleration, then we might see that. But generally speaking, I think the industry is solid in terms of their deployment strategies.
All right. Well, speaking of specifications, since this session is entitled Docsis on the Road to 4.0, let's talk a little bit about 4.0 and the new specifications around it. Since the specifications came from Cable Labs, Curtis, I'll perhaps turn to you to bring us all up to speed on maybe, what is Docsis 4.0? How does it differ from 3.1? And
yeah, so speed, you just mentioned speed. So it's all about speed, low latency, et cetera. It's all about the 10G platform, of course. Just to level set, Docsis 4.0 has two modes of operation. One is full duplex, which uses a top downstream frequency of 1.2 gigahertz. And then that full duplex part of the spectrum goes from 108 to 684. The other mode of operation is typically referred to as extended spectrum. It's a frequency division duplex mode of operation, so we often refer to it as the FDD mode as compared to FDX. And in that mode of operation, top downstream spectrum is up to 1.8 gigahertz. And then between that same band of 108 and 684, that's an upstream only band in the ESD part of specifications. So although we have two modes of operation, fortunately, they're both providing about the same downstream and upstream capacity. Downstream is 10 gig, approximately 10 gigabits per second. Upstream is 6 gigabits per second. Both of them are going to leverage the distributed access architecture, and in theory, both require a point of entry cable modem. So at that level, that's a pretty good level set on what Docsis 4.0 brings to the industry.
Very good. And are these specifications more or less completed, or they're more on the way?
I don't know if our specs are ever really complete. We issue specs, and generally that allows the industry to get started on deployment, whether that means network changes or device development. But we definitely we've issued them, and especially as interoperability events ramp up, we'll find some things that need to be changed, and then we'll use the Cable Labs engineering change process to make whatever those changes are that are necessary.
Very good. Now, Dean, what will be the SCTE's role in enabling the adoption of Docsis 4.0 technology?
Well, the first step to getting ready for Docsis 4.0 is to have the bandwidth of your cable network of your plant. That's always what leads that, and having CPE deployed. You need a network capable of the bandwidths or the frequencies that you'll be using, and you need to get CPE deployed. And I think the longer tail, the longer deployment time is on the network itself. So for over 2 years, the SCTE has been involved in updating standards, first to 1.2 gigahertz and now to 1.8 and or 3 gigahertz. In order to have our standards ready to go, and in order to enable the operators to deploy equipment now that will be ready for the next 30 years as far as frequencies go. Specifically there, we have at least three major areas. The first is what we've been calling the 3 gigahertz task force, which has looked through all of our existing standards and come up with standardized text on how to address whether this particular element, this component, such as a connector or a passive, can go all the way to 3 gigahertz or in the standard, or if it only goes to 1.8 or only to 1.2. And we've been working through those, starting with the most, you could call them mundane, but deployed everywhere things such as the F connector itself and the KS port, the 5/8 inch connector on the mainline equipment. So we've been going through those and updating all the standards to 3 gigahertz. in order to get ready for the eventual deployment of equipment that goes to 3 gigahertz. Related to that, then, we have a relatively new, it's been running for about half a year now, process to create our first TAP standard. The industry has never had an ANSI adopted standard for the TAP that goes on the hard line. And we will very soon now. That effort's, as I said, been going on for about half a year, and it's almost ready to go to ballot now. That's been led by Nick Segura from Charter, and it's been a great effort. Several people on this call have been participating. And so that's exciting. And the standard there will require a 3 gigahertz housing and then a 1.8 gigahertz faceplate. So the housing is able to go all the way to 3 gigahertz, enabling a faceplate change out at some point in the future, if and when the cable operator wants to go beyond 1.8 gigahertz. But we don't want to nobody wants to burden themselves with a faceplate designed at 3 gigahertz today and the cost of that. So it's a 3 gigahertz housing that holds a 1.8 gigahertz faceplate. And then finally, we will be starting up right after Expo. We're going to announce a kickoff to do 1.8 gigahertz active. So that's been requested by several of the cable operators together. And they're going to want downstream to 1.8 gigahertz and upstream to 684 megahertz. So just as Curtis was saying, for these higher bandwidths. And this will include specifications for downstream gain and upstream gain and powering, and even telemetry specifications, and perhaps a desire for some kind of a remote access using Bluetooth low energy or some other way to enable control of that box without having to put your fingers inside of it when you're working on it. But also to be local and craft related instead of either from the head end or from physically touching it. So all that having to say getting ready for 3 gigahertz, 1.8 gigahertz. And then another major area is in proactive network maintenance. And I think we'll talk more about that as we go forward. But if you want to get ready for these very complex signaling that goes across the network, then you want to take advantage of the tools that come along with it. And Docsis 3.1 and Docsis 4 have a very robust PNM standard that goes along with it. And there's multiple groups within Scte and Cable Labs working on proactive network maintenance. And I'll end with my plug for that. Here at Expo on Thursday at 11:30 is a session called PNM Live. You'll want to join that as industry experts actually show how they're actually fixing real plant problems using PNM.
Very good. So, Jan and Jay, one of the things that Dean just mentioned was, of course, before you can take advantage of 4.0, you need to prepare your networks accordingly. What are you seeing as far as your customers are concerned in terms of getting those networks ready? And what are some of the requirements that you think will be important for network operators who want to make sure that they've got a path forward to 4.0? Jay, why don't you start? See, Jay, I think, are you off mute, Jay?
Yeah, there
you go.
Yeah, sorry about that. If I was going to step back, I think sort of a synopsis industry wide is currently there's extensive focus on upstream capacity enhancement with Docsis 3.1 technology. I think MSOs are looking to make use of that to the greatest extent possible. Certainly from a North American standpoint, a mid or a high split upgrade program is imminent for pretty much every MSO. I think very shortly thereafter, as those programs start to launch, the next focus point is 1.8 gigahertz extended spectrum or full duplex technology. And as it relates to the 1.8 gigahertz, as Dean said, I think there's definitely a mindset of any 1.8 gigahertz equipment that would go into the network should have the ability to support 3 gigahertz, which is being touted as the next frequency point at which the network will be pushed to support.
Jan, what do you see?
Yeah, so if you want to go to 1.8, I think that's the main challenge. If you do higher frequencies, you will have higher loss in the network. And I think there will still be a lot of discussions going on, because if you look to the drivers of a network, one of the big drivers for the coax is to reduce the total cost of ownership. And if you want to reduce that, a big part of it is maintenance and power consumption in your network. I think the Scte did a calculation on it that 80% of the power consumption of a cable company is in the access network. So by going to even higher levels and more gain, etc., to overcome that loss, that power consumption will even go up much higher, and that fits not really in the ideas, I think, of being more green for the future, is to start to burn much more power inside networks. So I think there will still be discussions. There are different ways of doing this with the distributed gain architecture or other ideas how we can overcome this part. But I think the drivers for the future will be that part. You don't want to replace your CPE if not needed. You want to keep it the power consumption as low as possible, and of course you want to reduce the maintenance, the future maintenance of your network. And I think that are points of discussion going forward. And especially I think what Jay says is that you go from low split to mid split to high split, and all these actions are always required a lot of labor. And that also requires a lot of cost, of course, for the future.
So along those lines, I guess one question in terms of the steps you folks were just talking about, is the technology necessary to do that available now, or is some of it still to come? Maybe, Jan, why don't you start?
Yeah, we are developing a number of products like the passives, outdoor taps, etc., amplifiers, distributed gain amplifiers, mid-span amplifiers. So we have a whole range of products to meet the 1.8 requirements for the future. All of these products will come to the market by the end of this year or early next year. So yes, I think the products will be there. I think if then an operator it will still take a few years before they go to 1.8 gigahertz. But if you can buy a tap now, for instance, that is 1.8, why would you not do it? Why, if you need to install anyhow, then that's I think the future for or at least it is a decision that you do now to avoid cost in the future. So all the products that we develop will come to market by the end of this year, or there's even in a few months, or early next year.
Jay, what's your perspective?
I concur with what Jan had to say. From an active standpoint, all of the enabling technologies in terms of chipsets are pretty much established. There's a little bit more work to be done, but they're getting very close for prime time. So actives amplifiers should be available at the end of the year or in the middle of 2021. Not convinced that MSOs will deploy them imminently. There's a lot of work on the MSO's side to do in terms of network design, in terms of figuring out what diplex splits they'll want to deploy. But the technology will be there. From a passive standpoint, ATX actually offers 2 gigahertz faceplates and 3 gigahertz housings today. A number of MSOs have taken a look at those products, and once again along the lines with what Jan said. I mean, if I was an MSO, I mean, I would be deploying those types of products, if for nothing else, on a maintenance mode standpoint. I mean, if you're rolling a truck out to that site, why not put a 1.8 gigahertz or 2 gigahertz device in the plant? I mean, there's no impact to legacy system performance, and in essence, you're saving yourself a truck roll in the future.
So Dean mentioned that there are basically 2 modes of operation. There's the full duplex mode, which of course has been discussed since Docsis 3.1 was founded or ratified, and then of course the extended spectrum. What's your sense as far as interest in each of these technologies and operators, and is one going to get more attention initially than the other? Dave, maybe I'll start with you.
Me?
Yep.
Oh, yeah. I mean, certainly Comcast is leading the charge with respect to the full duplex technology, and Charter and a number of other MSOs are more interested in the extended spectrum. So I would argue they're both getting equal emphasis at this point, and we'll see where things go.
Yeah, I agree, Jay. I think both modes of operation are getting pretty equal emphasis in terms of development, whether it's in the plant or in the devices. I think they're both right now. People are pretty focused on both of them.
Right. Mm-hmm. Ben, what are you? Can you talk a little bit about your plans? I don't know if you're necessarily planning for 4.0 right this second, but as far as prepping your network to handle increasing bandwidth demands, what have you got up your sleeves?
Yeah, no, not quite yet, but that's why this is all good conversation for myself and other providers to hear this. We're always looking for, as the panelists have said, making good investment now to prepare us for the changes we need to make in the future. And so what we're probably looking at as next steps is the jump to 3.1 and use of the OFDM type of channels to get more out of what we have today. But we're very interested in those next steps, especially in the plant, what we can do to as we go through maintenance and improving our plant performance today. How do we improve it for better technology down the road in the future?
Mm-hmm. So let's see, we're about halfway through our program here. I will remind those of you in the audience that if you want to join in the conversation, just type in a question and hit the submission button. As hopefully you can see, we've started to get a few questions from the audience, so you can react to those, upvote them or whatnot if the audience member has asked a question that you're curious about as well. So we talked a little bit about architectural evolutions for prepping for 4.0, and of course one of the big architectural evolutions going on right now is the move to distributed access architectures. How does this move, the move to DAA, how does that fit together with Docsis 4.0? Maybe, I don't know, Curtis, if you've got a sense of what the vision is.
Yeah, I mentioned it earlier that Docsis 4.0 more or less assumes the presence of Ethernet to the edge. And so in that sense, distributed access, the architecture, as well as Docsis 4.0 devices in the form of remote PHY devices or remote MAC-PHY devices, they're complementary. And I think that's really one of the best things operators can do as they wait for Docsis 4.0 technology is to build out that distributed access. If you're going to do RPDs or RMDs, go ahead and build out Ethernet to the edge. It's going to be critical. And today you can deploy Docsis 3.1 RPDs and RMDs, and they perform extremely well, as we've heard from sessions earlier today. How much the lifespan of Docsis 3.1. So they're very complementary, and that's what where the emphasis should be.
Mm-hmm. And once again, are we more or less set on standards with the previously mentioned caveat that standards are never really set? But I mean, are there initiatives underway, let's say, that complement DAA, or is that pretty good?
Very, very relevant to DAA are of course, the remote PHY specifications, which have been in existence and issued for quite a while. The other side of that equation is the flexible MAC architecture, or FMA. It's really a true disaggregation of the Docsis network. We just issued our first spec for FMA about 12 days ago, which is really a huge milestone for the industry. And at Cable Labs, of course, we couldn't have done it without our members and our vendors. The other component really is that point-to-point coherent link, as well as the device that will end up in an aggregation node that terminates that coherent link and breaks out the links into gray optics to the edge. So, I kind of said at the beginning, we've got this covered, and the industry is behind us, and we're moving pretty fast with it all.
So, Jay and Jan, what are you seeing from your customers in regards to DAA deployments and strategies? Maybe Jan, I'll start with you.
We see this happening more on trial locations and big deployment. I think we are all waiting for the next generation chipset. Also coming back to my previous answer that power consumption is very critical, very important going forward in the networks. And the next generation chipsets promise a remote PHY / MAC-PHY situation where the power consumption will be much lower. We are already delivering our access platform with the amplifiers here. We have delivered over 1 million of these types of amplifiers, all prepared for DAA. All of them are upgradable, field upgradable, that if the operator wants to make the step to go to a remote PHY or to remote MAC-PHY, then these equipment can be upgraded in the field and can be rolled out quite easily. So we see this happening. We see also our customers are trialing and doing more and more in this area. But I think the real big rollout still has to come if the next generation chipset comes around.
Mm-hmm. Jay, what are you saying?
I would agree with everything Jan said. I mean, there's some exciting developments on the chipset side that really reduce cost and power as it relates to DAA modules inside of nodes. And similarly, from our standpoint, we're seeing a lot of trialing, a lot of proof of concept, as opposed to any mass rollout, short of maybe 1 or 2 MSOs. And I think certainly the COVID factor played into this and pushed things a little further out to the right. But certainly we view 2021 as the point in time where operators, as they're doing mid-split or high-split upgrades with respect to Docsis 3.1, they'll be pushing out remote PHY based or remote MAC-PHY based devices into the field to start to build out that ability to support DAA in the fullest extent as Docsis 4.0 will require it.
So, at least at the beginning, the evolution of DAA seemed to be described as pointing towards a node plus zero architecture. Are you seeing operators indeed going down this path, or maybe not so much? Jay, I'll start with you.
Yeah, I think early on, this would be going back a couple of years, DAA, RPD, node plus zero, they were all sort of wrapped into the same sentence, if you will, or all meant the same to a lot of people. But that's truly not the case, where node plus zero is an HFC architecture and DAA is actually a technology that gets deployed onto that architecture. I would say, while node plus zero was certainly the significant buzzword, let's call it 3 years ago, and a large number of operators were focused on that as their move forward plan. I think there's been a pullback from that, and certainly both on the FDX front and on the extended spectrum Docsis front. They're from an extended spectrum Docsis standpoint, I mean, inherently it's an architecture that's to be deployed without having to go to node plus zero. And even on the full duplex side of things, the concept of a full duplex amplifier reared its head probably a year and a half ago, with the intent being to be able to deploy full duplex technology in a N+1 or an N+2 architecture. So I think that necessity or desire of the end game of node plus zero is diminished significantly since the last couple of years ago.
Jan, what are you seeing?
Yeah, I think the big driver for N+0 was full duplex Docsis. We couldn't handle diplex filters in the network, and that's why we had to go to N+0. That was the only solution to do real full duplex Docsis. I think, as Scte said, we want to have 10 gigabit down and 6 going up. That means that you have a big area that up and down will be done simultaneously, and that's why filters cannot be used anymore. I think that has now been changed. Also, we developed an amplifier without those filters, and that's what makes it feasible to still have amplification in the network, while the downstream will go all the way from the 85 up to 1.8. And the upstream can still go to 684, and then you can have both directions gain at the same time. That will solve the problem of have to go to N+0. extended spectrum Docsis was the reason we started expanded spectrum Docsis was that we didn't want to go to N+0 because that was the driver. We didn't want to go all the way down in the network. We want to keep our N+3, N+2 networks, and still to achieve that goals for 10G. That was the option to go to higher frequencies where you have more space for the upstream and you have more space for the downstream. So I think extended spectrum Docsis was never N+0, but full duplex was it a couple of years ago, as Jay said. But I don't think that will still happen going forward.
All right.
But that also then will cause a problem, I think, without going too much details in full duplex Docsis, because with full duplex Docsis, where you have gain in both directions, we still have to overcome, of course, some discussions about interference groups and things like that. If you start to connect more and more homes to one remote PHY device with amplifiers.
Mm-hmm. So speaking of amplification, maybe we can start working in a few questions from our audience. One audience member wants to know whether Docsis 4.0 ESD will require any changes in amplifier spacing. Jan, do you have a thought on that?
Yes, I have a big thought on that. Thank you. I think it's yes. There are at the moment, I think, two parts. One part is that we can go for high power, high gain, high level amplifiers that we don't have to go to amplifier respacing. That has a benefit that you can keep the amplifiers on the same place. You can keep your network structure on the same location. But the problem is that your power consumption, etc., will go really high. And the downside is also that the quality will never be able to deliver 4K QAM into the network, because you will lose too much quality in your network by having to go that high on the frequencies. Because don't forget, on the hybrids we can buy now on 1.8 gigahertz are not so good as the hybrids we could buy on 1.2. The total composite power, such a gain block can deliver on 1.2, is seriously higher than the gain blocks on 1.8. So instead that we can go to higher levels, we have to reduce the level to still meet the quality. That's a problem, and that's why there are solutions to go to zigzag tilt or things like that, and that will solve the problem for the total composite power that an amplifier has to deliver. But it only increased the problem that the levels that you receive on the next amplifier will be so low that therefore the noise kicks in too much, and therefore your MER will drop too far. And that's why you have to really switch back to maybe even below 512 QAM or something like that, instead of 4K QAM. Other solutions that you see now is a distributed gain architecture, or that you can have amplifiers that in the middle we put in a small mid-span amplifier, a small booster, that will help you that the signals will still arrive on the next amplifier. So you don't have to do the respacing, but you don't have to go to the high levels either. And that small amplifier at the end will be much more efficient for the power consumption, because it can reduce the power consumption network with over 40%, while it increases the quality of your network. So I do believe that that's the way forward, is not to go to those high levels, but to start to work smart instead of hard, and putting in small booster amplifiers to overcome the loss you get in the network on the higher frequencies. And in that case, you don't have to go to amplifier respacing. You can keep them on the same place, and you don't struggle with the part that you have to go to zigzag tilt or whatsoever. You can just keep the gain as is, the tilt as is, but you get helped halfway the line to overcome the loss. So I think, yes, that's absolutely, I think, the main question at the moment. If we go to 1.8 gigahertz, can we keep the network as is? Yes, we can, if we do that clever. Yes, we think so.
Dean, I think you've got an opinion on this.
No, I totally agree. And I just wanted to point out to everybody watching here, we're in the beginning of Expo Week, and we have the Fall Technical Forum. And having been on the program committee and watching the paper submissions, and even being a peer reviewer of some of the papers, I would say, be sure that you're attending these sessions, because what Jan just said is absolutely true. I reviewed a session that's tomorrow at 3 o'clock. It's called Extended Spectrum and Amplifiers, What's Happening and What Needs to Happen. It's a great session on the same topic. So I just want people to be aware of how much information is here at Expo. That particular session has a paper by Shaw Communications that describes what Jan was just talking about. And so what are the trade-offs between requiring lots of amplifiers or maybe using all the power in Docsis 4 to use different orders of modulation at different frequencies in order to, and for customers on different taps. So there's a lot of clever ideas being discussed, and I just wanted to remind everybody to take advantage of this, of all the papers being presented this week.
Jay, do you have a feeling on amplifier spacing?
I think the guys covered things really well, and there certainly are options. I mean, but to step back and reflect on the genesis of Docsis 4.0, the full or frequency division duplex stream of that technology, the whole thought process behind it was, can we extend our capacity by pushing up the frequency to 1.8 gigahertz? And by the way, can we do it via drop-in upgrades? Because MSOs definitely did not want to do an entire network rebuild. So I think that the drop-in upgrade concept has been shown to work through analysis, as we did a number of cascade analyses. 100% agree that certainly at the higher frequencies, due to the significant attenuation in the network, we're going to see modulation rates that will drop lower than maybe what's desired, but it'll still drop to levels that you'll still be able to push capacity through that portion of the frequency spectrum. And this really is where adaptive profile management, that tool within Docsis, really starts to add a lot of value. MSOs don't necessarily have to design their networks to some common denominator across all cable modems. With the adaptive profile management, different cable modems can adapt to different modulation densities.
Very good. Now here's an interesting question from an audience member. And again, if you're in the audience, you want to ask our panelists a question, now's the time to do it. We've got a little less than 15 minutes to go in the session. Just type in your question and hit the submission button. The audience member wants to know, how do you see Docsis 4.0 playing with the expansion in the wireless spectrum? How does Docsis 4.0 and wireless pair together? Maybe Curtis, I'll start with you. Has Cable Out's been thinking about Docsis 4.0 or advances in Docsis in the context of wireless as well?
Well, I'm not sure if the submitter is referring to wireless wireline convergence. So I'll answer based on that assumption that once you get to a 10 gig downstream and then a 6 gig upstream, your ability to leverage your HFC assets for providing capacity to whether it's a cell site or a fixed wireless access, they're very complementary. And you know, we said this when 10G was first launched, that 10G and 5G are very complementary, and it all boils down to the capacity and lower latency that are going to be possible with Docsis 4.0. So I'm assuming that's what the submitter was referring to, but certainly if it wasn't, they can rephrase the question. Very
good. So one topic that's come up a few times, of course, is increasing bandwidth in the upstream. Ben, I'm curious from your perspective, how important is the upstream for you? Is it a competitive issue, and you know, what are you doing to improve your upstream capabilities?
Yeah, upstream is very important, and it's a competitive advantage, I think, to fiber providers. Traditionally, I think that's where fiber has had an advantage over cable systems. But I think that these new technologies are catching up, and it is a big issue for us. We actually have an offering where we offer to double your upstream. That way, you know, customers that want it and appreciate it have the option to get it. But what we've seen also, and I've heard a lot about in the industry, is that a lot of the public fundings, the federal funding, state fundings, are having upstream thresholds to meet that threshold in order to get the funding. And so I think what a lot of operators are dealing with is whether they have to use fiber in order to meet that threshold, or whether they can utilize newer Docsis technologies to get to those upstream thresholds in order to qualify for the funding.
So why don't maybe Jay and Jan, you can perhaps help answer that question, particularly if you're on a program time frame dictated by a government funding that you're receiving, you know, how do you quickly upgrade your HFC upstream capability to meet requirements? Jay, maybe I'll start with you.
Yeah, I mean, certainly if you're assuming it's HFC plant that you need to upgrade, pretty much every amplifier platform that exists in networks today, assuming they're supporting in the neighborhood of 870 or 1 gigahertz, should be modular upgradable. And in this case, it definitely minimizes the amount of labor involved, where one amplifier module is removed and another is put in with a mid split or a high split upstream performance associated with it. And really, that's all you need to do from a outside plant perspective. TAP should be solid to support that, and then of course you need to address a similar node. The amplifier section of the node would need to be upgraded. Ideally, it's modular upgradable as well, and depending on whether it's an RPD module or if it's more of a centralized architecture, some work at the CMTS side of things would need to be done to support the upstream.
Jan, what do you think?
No, I think yes, upstream is very important, and I think if you look to it at the moment, we are depending in the US or Europe, you're on 4254 or on 6585, and we want to go to a mid split or a high split, or maybe in the future, as I think Scte said, that even the split can go all the way up to 684, and there are a lot of steps of 96 megahertz in between to come there. So therefore, all the amplifiers that we deliver will have filter upgradable. So that means that you come there, you replace the diplex filters, and in fact, the software will take care of the rest and align your network for you. That will speed up the installation, etc. And again, that is to reduce the TCO as much as possible. But I think that also, if you really look forward, the distributed gain can help you, where we are talking about removing diplex filters, and that you are building more a transparent pipe, that in fact where you put the split is a decision of the remote PHY and your CPE equipment on the other side, and that you can just move around the split how you want it. So if you need more upstream, you can move it up. If you need more downstream, you can move it down again. That is something that I think that if you look forward in 5 years' time, will be something that will be deployed, and that also will take care of the guard band. Because at the moment, the guard band is okay if you have 4254, because you only lose 12 megahertz. But if you go all the way up to 684, you will lose somewhere between 120 and 180 megahertz, very good usable frequency space. And that's not something you want to lose in the future. And that's why those technologies where you don't have that split anymore makes it easier, and you have much better use of your bands, because then your upstream can stop at 684, but that means that your downstream can start at 685. And that's why you don't lose that 120 to 180 megahertz anymore. So it's an issue at the moment that you need to replace diplex filters, but I do believe that in the future that issue will go away, and that will give, as Ben said, give him also the option that if he needs more upstream, he can just do this remotely, etc., because you are building a much more transparent pipe going forward.
Very good. So see, here's another question from an audience member who wants to know, how is Docsis 4.0 going to improve latency over Docsis 3.1, assuming that the cascades stay the same? Maybe I'll start. Curtis, is there anything in the specs specifically about latency?
Well, it's actually a good question. The ability for Docsis to deliver low latency in Docsis 4.0 is really the same as it is in Docsis 3.1. So with the exception of just having an increase in capacity, which somewhat inherently improves the latency aspect, 3.1 and 4.0 are both doing low latency in the same manner.
So Jan and Jay, if somebody's looking to lower the latency in their networks, do you have a suggestion for them? Maybe Jan, I'll start with you.
I think there are discussions at the moment between remote PHY and remote MAC-PHY. And I think there is remote PHY, remote MAC-PHY will help us with that part a little. But I think it is more to it's not in the network itself that is doing this. It is more in the software area, but Curtis says That's the part that the Docsis protocol has to look after. So that's so for the network itself, it's not causing the that's not causing the delay. It comes out of the protocol.
Jay?
Agree 100%. It's a MAC scheduling issue that's really driving the latency, and that's being dealt with.
Right. So, okay. So speaking of remote PHY and remote MAC PHY, we've got about 5 minutes to go. So we'll hopefully do this quickly. Amongst some people, the thought had been remote PHY and remote MAC PHY were kind of religious issues, and you either liked one or you liked the other, but you didn't necessarily like them both. Is that indeed true, or are you finding that operators are perhaps going to be using these selectively, depending upon application requirements going forward? And maybe Jay, I'll start with you.
Yeah, I think some operators have made their decision to move forward on remote PHY indefinitely. I think a number of other operators look at remote PHY as phase one, and will roll that out as they establish their DAA network. Probably for a couple reasons. One being the fact that there's definitely the opportunity to leverage incumbency in their existing networks, in that they can upgrade CMTSs with remote PHY capable line cards as opposed to RF based line cards. So there's definitely some value there for cable operators to extract. I think another reason is just where the remote MAC PHY spec is at. It's now been ratified or pushed out by Cable Labs, so that was obviously a big step forward. But and that was fairly recent, I think the last couple of weeks. So there was definitely some hesitation around operators with respect to moving forward on a technology that was not fully standardized. And then just number of vendors in the space has been fairly limited. I think that could grow over time, and it feels like, from where we sit, there are definitely a number of operators who will migrate over the longer term to remote MAC PHY.
All right. So we've got about 3 minutes. Go ahead.
Yeah, I just wanted to point out that the good thing about the FMA specifications is that it leverages both remote MAC PHY as well as remote PHY. I mean, inherently there's a remote PHY device inside a remote MAC PHY. And so if you split out that MAC into not all the way back to a virtual CMTS, but you just split it out, and we've got a MAC manager interface that's specified. I think you'll see potentially networks that leverage both. As Jay said, an operator will probably settle on one or the other, but in any case, the latency issues, and I haven't heard too many latency issues with remote PHY recently either. They'll all get solved. We'll all solve them for sure.
Yeah, but I do believe that the power consumption will be a big player in this area, because at the moment the power consumption that you see to a remote PHY device is much lower than remote MAC PHY. But if you look to the new chipset that there are announced, then that will be much smaller, and that's why we at the moment we are even looking to a remote MAC PHY 2x2 with 4 high-level outputs below 90 watts. And that is, of course, a big step forward to the exception of remote MAC PHY. Yeah. I think that will be a new step. That is the driver to create a MAC PHY solution on low power. Then there is not many reasons not to go for MAC PHY anymore.
Very good. And with that, I believe we've just about come to the end of our program today and the end of our time. I want to thank all of our speakers for sharing their expertise. I'd also like to thank ATX Networks, Technetics, and Corvo for their help in making this event possible. I'll just bring up their logos there for a second. Thank you. And of course, want to thank you in the audience for attending. Hope you enjoy the rest of the SCTE Cable Tech Expo virtual experience, and hopefully next year it will not be virtual. We'll be seeing you live, and we'll bring bacon next time. Again, thanks a lot. Have a great rest of your day, and goodbye.
We hold you that. Thank you.
Thank you.
Thank you.
Bye-bye.
Yeah, everybody.